Alrighty, here is the test review for you. On number 5, now remember the numbering on here is just crazy and it's just not worth my time to fix most of the time. So we're going to start with number 5. It says, using the leading term, give the end behavior of each polynomial function. Okay, all I want here is the arrows, up, up, down, 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 up, whatever. Here's a mistake I saw quite a few people do on the quiz. It took me a while to figure out why everybody was missing something so easy. Yes, there have been times when we have counted up the x's, I guess you could say. So for instance, if I had x minus 3 squared times x plus 2 times x minus 1 cubed, and I wanted to know the degree, I would have to think, okay, well, what would this be if I did multiply it out? I'd cube this one, that would give me 3 x's, this would give me another one, this would give me 2 more, so that would be a total of 6. That's when you count them up. Here, this is multiplied out. Counting up the x's here makes 0 sense. So I already know, I can tell by looking without having to count anything, that 6 is the highest exponent. So that is my leading term. That's going to tell me that it's even, so the ends are the same. It's either up, up, or down, down. And it's positive, so my end behavior looks like this. This one, this next one, x to the 8th, this is even, and it's negative, so this is down, down. That doesn't even look like an arrow. Down, down. Okay. All right, so then we're given a graph, and we're going to do the same type of thing. And another mistake that a lot of y'all did on the quiz, which I even said when I handed it out, is make sure you use the words like power and coefficient, or degree, or in coefficient. I think on this one it says degree, on the quiz it said power. It really doesn't matter either way. It's the same thing, and coefficient. So number 9, these are opposite. So this is an odd power or odd degree, you can say it either way. And this would be a negative coefficient. All right, so these are even because they're the same. So this would be an even power or even degree, and a negative coefficient. All right, so then 11, the ends are opposite, so that makes it odd. And it has a cubic look, so this is a positive coefficient. All right, there you go for those. Number 12 says to divide the polynomials using synthetic or long division. And what I should have said, I thought I said it on here, I know I said it on the test, is use synthetic division when possible. Okay, so if you can use synthetic division, I want you to, because I want to see that you can do both kinds. After this, if you choose to do one or the other, it's totally fine. But on number 12, I can do synthetic division, so I'm going to. So I know that negative 2 goes on the outside. Then I have a 3, a 9, a 0, and a negative 9. This is a third degree polynomial, so I should have 4 numbers in here. I am missing my x term. That's where my 0 goes. Cannot forget that. Okay. So then I'm going to run through my synthetic division here. I'm going to bring down my 3. Negative 2 times 3 is negative 6. It gives me 3. Negative 2 times 3 is negative 6. It gives me negative 6. Negative 2 times negative 6 is 12. That gives me a positive 3. So then when I go to write my equation, because all it asked me to do here was divide, except on number 13, which we're not at yet. So all it asked me to was divide, so I just need my answer. There are 3 terms, so that means this is 3x squared plus 3x minus 6 plus, because I always add my remainder, 3 over x plus 2. So the directions state that on 13, I also need to fully factor it and state the zeros. Okay, so I'm going to start off by doing my division like I know how to do here. So on the outside, I'm going to have 1. On the inside, I have 1, negative 1, negative 13, 13, 36, and negative 36. Then bring down my 1. 1 times 1 is 1. That's 0. 1 times 0 is 0. Negative 13. 1 times negative 13. Negative 13. 0. 1 times 0 is 0. 36. 1 times 36 is 36. My remainder is 0, which I would expect because I'm supposed to continue and factor this, and I can't do that if I don't get 0 right there. All right, so then that means I'm going to need to factor this. I'm not just going to write out my answer like I did on this one. F of x equals, I have divided this part out, so I know that this times whatever I get from here should equal my original one. So I have x minus 1 times. Now there's 1, 2, 3, 4, 5 of these, which means this has to be x to the 4th. There is no x cubed term, minus 13x squared. There is no x term, plus 36. Okay, and then I need to factor that trinomial there. It's a 4th degree, but I can treat it just like a quadratic. So I'm going to have f of x equals x minus 1 times, all right, a is 1, so I can jump to the 2 parentheses. I know that this is x squared and x squared. This is positive, so the signs are the same. This is negative, so they're both negative. Two numbers that are going to multiply to give me a positive 36 and combine to give me a negative 13, be negative 4 and negative 9. I can continue to factor. F of x equals x minus 1 times x plus 2 times x minus 2 times x plus 3 times x minus 3. So this is my fully factored form. Then my zeros, I would have plus or minus 2, plus or minus 3, and 1. And there you go. All right. When I look at the next one, I cannot use synthetic division because I have a 5 here. Okay, so I'm going to have to use long division. So when I do my long division, 5x minus 1 goes on the outside. On the inside, I'm going to have 20x cubed minus 4x squared plus 10x plus 1. Remember to look for missing terms. This is a cubic. I should have 4 terms. I have 4 terms, so I'm fine. All right, so then 5x goes into 20x cubed, 4x squared times. Then I multiply and I get 20x cubed minus 4x squared. Then I change the signs. Don't forget to change the signs. These zero out. These zero out. Okay? So I haven't done anything wrong. They just all zero out. So I have to bring down my 10x. And then I also have to go ahead and bring down my 1 since all that stuff zeroed out. 5x goes into 10x a positive 2 times. So I'm putting it over there so I know I'm kind of done with that stuff. And I get 10x minus 2. I change the signs. These zero out. This gives me 3. So my answer is 4x squared plus 2 plus 3 over 5x minus 1. And there you go. All right, number 15. Dividing, again, I cannot use synthetic division because this is not a linear and it's not a binomial. So on the outside, I have x squared plus 6x plus 1. On the inside, I have 3x cubed plus 20x squared plus 14x minus 8. Once again, I should double check that I don't have any missing terms. This is a cubic, so I should have 4 terms, and I'm good. I don't have to put any zeros anywhere. All right, so now x squared goes into 3x cubed 3x times. So when I multiply, this gives me 3x cubed plus 18x squared plus 3x. Then I'm going to change the signs on each term. These zero out. This gives me 2x squared plus 11x minus 8. X squared goes into 2x squared a positive 2 times. So we get 2x squared plus 12x plus 2. Go in there and change my signs. These zero out. I get negative x minus 10. So my answer then is 3x plus 2 plus, because I always add my remainders, negative x minus 10 over x squared plus 6x plus 1. That's my answer. All right, that's page 1. Let's look at page 2. Page 2 says to use the remainder theorem to evaluate f of x at c. So remember, if I want to evaluate f of x at c, I'm looking for f of 3, basically, and want to figure out what that is. And I can do that using synthetic division. It's called synthetic substitution. And I just take this 3. So I don't change the sign because this doesn't say x plus 3. It just says c is 3. And I can use my synthetic division. So on the outside is 3. On the inside goes 1, negative 4, 1, and 6. Right. Then I'm going to do my synthetic division. Bring this down. That's 1, 3, negative 1, negative 3, negative 2, negative 6, 0. Okay, so my remainder is 0. What that tells me is that f of 3 equals 0. My remainder is my answer when I'm evaluating using that synthetic division. Right, so then number 17, negative 2 on the outside. On the inside, well, let me just tell you on number 17, if you get negative 69, that answer is not right. Pretty sure I know what mistake you made. In here I have 4, negative 3, 0, 7, and negative 11. Because I have a 4th degree, I should have 5 numbers in here. I'm missing my x squared term. That's why there's a 0 right there. Okay, so then bring down my 4, get negative 8. That's negative 11. That gives me positive 22, negative 44, negative 37, positive 74, positive 63. So f of negative 2 equals 63. All right, number 18. I know that 1 goes on the outside. That's a 4th degree, 1, 2, 3, 4, 5. I have 5 terms, so my numbers will take care of themselves. I have 1, negative 6, negative 3, 2, and 2. Okay, bring down my 1. 1, 1 is 1, negative 5, negative 5, negative 8, negative 8, negative 6, negative 6, negative 4. So f of 1 equals negative 4. All right, one more of these. So I have negative 3 out here. Inside, 4th degree, 1, 2, 3. Oh, there's only 4 terms, so I got to put a 0 in here. I have 2, 5. The x squared term is what I'm missing. Then 3, then 4. So bring down my 2, negative 6, negative 1, 3, 3, negative 9, negative 6, 18, 22. So f of negative 3 equals 22. All right, so then it says use the factor theorem to determine which binomials are factors of the functions below. So remember, if it is a factor, then my remainder is 0 when I do synthetic division. So I'm going to start with that x plus 1, which means I'd have a negative 1 on the outside. On the inside, I would have 2, negative 3, negative 17, and negative 12. Okay. Do my synthetic division. Bring down the 2. Negative 2, negative 5, 5, negative 12, 12, 0. So since I got 0 as a remainder when I divided I did my synthetic division with -1. That means that this is a factor. So then I have the same numbers on the inside, 2, -3, -17, and -12. On the outside this time I'm going to have 4 to check that one. Okay, so I bring down my 2. This gives me 8, 5, 20, 3, 12, 0. So that means this one works because when I did synthetic division with 4, it was a factor. Then I'm going to have the same numbers on the inside again. 2, -3, -17, -12. On the outside this time I'm going to have a -3. Right. So I bring down my 2, -6, -9, +27, 10, -30, -42. So I got something other than 0 for my remainder, so this one does not work. Okay, so I have 2 that were factors, 1 that was not. There's my proof right there. All right, so let's do that on 21. On the inside here, I'm going to have, well, first of all, I have 4 terms, it's a 4th degree, 1, 2, 3, 4, 5, so they'll take care of themselves. I'm going to start on the outside with the -2. Okay, then I'm going to have 1, 4, -8, -35, -12. Okay, bring down my 1, -2, 2, -4, -12, 24, -11, 22, 10. Means this one does not work. I'm going to use these same numbers on the inside, but this time -4 on the outside. All right, so I have 1, 4, -8, -35, and -12. And bring down my 1. It's going to give me -4, 0, 0, -8, +32, -3, +12, 0. So this was a 0. I got 0 as a remainder when I did synthetic division with this, so this one is a yes. I'm going to use my same numbers on the inside again. 1, 4, -8, -35, and -12. This time on the outside, I'm using 6. Bring down my 1, it's 6. 10, 60. Right? Add those, I get 52. 6 times 52 is 312. 312 minus 35 is 277. 277 times 6 is 1662. And this is 1650. That clearly does not work. The zeros and their multiplicities and the effect on the graph. So on the quiz, you had 2 problems very similar to this. Almost every single person did the first one just fine. Factoring this is the downfall of some of you. Some of you that have been struggling are doing so much better with factoring. Keep that up and do not regress. Others of you, I don't know what the heck you're doing, but we'll get there in just a second. Okay, so the first thing I want to do here, it's already factored for me. Beautiful. I can just figure out what my zeros are. So my zeros are -7, 0, and 3/2. So -7, 0, and 3/2. The multiplicity for -7 is 5. The multiplicity for 0 is 3. The multiplicity for 3/2 is 2. And I even said when I gave you the quiz, don't use the words like bounce and wiggle, use the real terms here. So if I have an odd, that makes this a point of inflection. That we've used that so much now, I expect you to know the word, not some other made-up word that you think is right. This would also be a point of inflection. And this is even, so that would be tangent to the graph. Okay, so let's look at 35. I need to factor it. So I'm first going to factor out the GCF. Okay, my GCF, and your GCF on the quiz was not only a variable, it was also a number, which would have made your life a lot easier. But I got a GCF here. I'm going to factor out my x cubed. So f of x is going to equal to x cubed times x cubed minus 2x squared minus 4x plus 8. Okay, so then I'm going to factor by grouping. Okay, I still have this x cubed out here. And then I'm going to use brackets because I'll have extra parentheses. Out of these two, I'm going to factor out an x squared. And that leaves me with x minus 2. Out of these two, I factor out a negative 4. That leaves me with x minus 2. Then I get f of x equals x cubed times x minus 2 times x squared minus 4. And I can keep going. So f of x is equal to x cubed times x minus 2 times x plus 2 times x minus 2. Well, these two are the same. So this should be f of x equals x cubed times x minus 2 squared times x plus 2. If you don't actually condense it like that, you are likely to not pay attention to one of your multiplicities. I would also go back and make sure you can factor and look at the one that's like this on the quiz. So then from this, my zeros are plus or minus 2 and 0. Okay, so I have a negative 2, a 0, and a 2. So negative 2, the multiplicity is 2. 0, the multiplicity is 3. Oh, not negative 2 is not multiplicity of 2. Dang it. Sorry about that. Negative 2, the multiplicity is 1. 0 is 3. 2 is a multiplicity of 2. When it's a multiplicity of 1, it just passes right through the graph. Nothing fancy. Just passing on through. Odd makes it a point of inflection. And even makes it tangent. Okay, and that concludes page 2. Well, let's look at page 3. So on page 3, I told you this, I intended to delete this. We have not talked about the rational zero theorem yet, so you can factor these and find the zeros, and that's really not bad practice. But it's, yeah, we're just not doing that right now. Okay, so let's jump to 48. It says determine if f of x has an inverse. If yes, find f inverse and state any restrictions on the domain. Okay, so this is a cube root, right? So my cube root looks like this. If I have any restrictions on the domain of the inverse, it comes from the range of the original one. Well, the range of my original function is all real numbers, so there is no restriction. And it is a one-to-one function, therefore I can find the inverse. So now I'm going to find the inverse. I'm going to replace this with y. I'm going to switch x and y. So I get the cube root of y minus 7 plus 2 equals x. So I'm going to subtract 2, so the cube root of y minus 7 equals x minus 2. So now I'm going to cube both sides. Y minus 7 equals x minus 2 cubed. So y equals x minus 2 cubed plus 7. So the inverse, f inverse of x, which I expect you to write with your final step, is x minus 2 cubed plus 7. Okay. All right, so let's look at 50. Well, this is a quadratic. So if I was to graph my quadratic, that's a vertical stretch, and then it goes down 7, so it's down somewhere here like this. This is not a one-to-one function. However, I have this domain restriction right here that says x has to be greater than or equal to 0, so it's really just that part. That is a one-to-one function. All right, and then also, so it's a one-to-one function. I can find the inverse, I know that. There is a restriction on the domain in the end because this range is not all real numbers. The range here, I went down 7, so it's from negative 7 to infinity. Okay, that'll help me with my domain in the end. So I'm going to set this equal to y. And they're going to switch places. 4y squared minus 7 equals x. So 4y squared equals x plus 7. Then I'm going to divide by 4, so I get y squared equals 1/4 times x plus 7. Take the square root of both sides. Y equals plus or minus the square root of 1/4 times x plus 7. And since it's an inverse, all I want is the positive one. So f inverse of x is equal to the square root of 1/4 times x plus 7. If you put it over 4 and then rationalized or whatever, that's fine. It's the same thing. Then I do have a domain restriction, and that is that comes from the range up here, -7 to infinity. And hopefully that should make sense to you, because I have to start at -7. If I substituted in a -8, I'd have a -1 times a -1/4, I'm sorry, times 1/4. Then I'd have a negative number under here, and that's not going to give me a real number. So that's why that domain restriction is important. Okay. On number 53, the fraction bar from the 1/2 disappeared. You probably noticed that. I don't know where it went. Sometimes they disappear. I don't know where they go. I've yet to figure that out. All right, so this says to verify that these are inverses both algebraically and graphically. So let's do this graphically first. So I'm going to draw in my line y equals x. That's my reflection line. That is part of the graph that you need. This is a cubic. So looks like this. I have 5 anchor points. So my first anchor point here is at -2, -8. I would have a horizontal stretch by 2, so that becomes -4, and I go down 3, and I'm off my graph. Okay, so then I'm going to go to -1, -1. Horizontal stretch by 2, down 3. Then I'm at 0, 0. No stretch, I just go down 1, 2, 3. Then I'm at 1, 1. Horizontal stretch by 2, down 1, 2, 3. Then I'm at 2, 8. Horizontal stretch by 2, down 1, 2, 3. Okay, so there's my graph. Remember the points I have. And when I sketch it in, it looks something like this. Okay. So that's this one. Then I'm going to do the cube root, which looks something like this. And at 5 anchor points again, I would start at -8, -2. Have a vertical stretch by 2, move to the left 3. I'm off the graph. -1, -1. Vertical stretch by 2, move to the left 1, 2, 3. 0, 0, move to the left 1, 2, 3. 1, 1, vertical stretch by 2. Oops, I didn't mean to put that point on there. 1, 1, vertical stretch by 2, move to the left 3. Then I'm at 8, 2, and vertical stretch by 2, move to the left 1, 2, 3. So then my graph looks something like this. You can see that, clearly see that they are reflections of each other, so that's good. Then it also says both algebraically and graphically. So I have to find f of g of x. So I'm going to take g of x and substitute it in here. This gives me 1/2 times 2 times the cube root times the cube root of x plus 3 cubed minus 3. So 1/2 times 2 is just 1. So now I have the cube root of x plus 3 cubed minus 3. When I cube that, I get x plus 3 minus 3. That all equals x, which is exactly what I expected, but I have to show my work about how I get there. All right, then I have to do g of f of x. So I take f of x, put it in here. Get 2 times the cube root of, instead of x, I put 1/2 x cubed minus 3. Then I still have this plus 3 here. So those zero out. So now I have 2 times the cube root of 1/2 times x cubed When I take the cube root of that, that's going to give me 2 times 1/2 times x. That equals x. And all is well. That's my verification algebraically. Verify graphically, verify algebraically. All right, last page. Compositions. I want h of g of f. I'm sorry, no I don't. I want h of f of x. If this confuses you at all, I highly suggest you rewrite it like this. H of f of x. I think that makes a whole lot more sense. I can see that I'm taking all of f of x, substituting it into h of x. So this is going to equal 3 times, instead of that x, I put in f of x, negative x squared minus 2x. Then I still have that minus 1. So this gives me negative 3x squared minus 6x minus 1. It's really all I can do. That is h of f of x. Okay. Then I want f of g of x. F of g of x. So I'm going to take g of x, put it into f of x. So I have negative square root of x plus 7 squared minus 2 times the square root of x plus 7. Right, so when I square the square root of x plus 7, I get x plus 7. So that's negative x plus 7 minus 2, and all I can do is stick those together, square root of x plus 7. Distribute that negative, I get negative x minus 7 minus 2 times the square root of x plus 7. That is f of g of x. So now I need f of h of x. I'm going to take h of x, substitute it into f of x. So this gives me negative 3x minus 1 squared minus 2 times 3x minus 1. Right, so negative, and I do not just square this and get 9x squared plus 1. Okay, there's a pattern to it or you FOIL it. But this gives me 9x squared. Multiply these two together, I get negative 3x, double it, negative 6x, and then square this, plus 1. And then I'm going to go ahead and distribute here, minus 6x plus 2. Now I need to distribute this negative, negative 9x squared, plus 6x minus 1, minus 6x plus 2. So these 6x's zero out. That leaves me with negative 9x squared plus 1, and that equals f of h of x. 140, we are deconstructing because it says I want to find two functions f and g such that f of g of x equals h of x. Remember that means f of g of x equals h of x. And you only have to give me one set. I'm going to put 2 sets on each one of these just so you can see there's other options. And there's other options besides what I'm putting as well. So I need to find an f of x and a g of x. G of x is easier to find first because g of x is what goes on the inside. So if I said, all right, I'm going to take this x minus 9. Let's say that g of x is x minus 9. Then when I do f of g of x would have to be f over x minus 2. Because when I substitute this in for x, I should get that back. That's one option. Or I could have f of x and g of x. And what if I said g of x is 5 over x minus 9? If that's g of x, then f of x would have to be x minus 2. So that when I substitute this in for x, I would get this back. Okay, remember, this is 2 sets. You only have to give me one set. So when it says 2 functions, this is your 2 functions. All right, then f of x here, g of x, and then we'll say I'll have an or over here, come up with 2. All right, so let's say that g of x is x plus 5. Then that would mean that f of x would have to be negative square root of 2x plus 7. Or I could say g of x is the square root of 2 times x plus 5. And then f of x could be negative x plus 7. And again, there's other options besides that, but that gives you some ideas there. Okay? And then last one, oh no, last one of the compositions. Looks like I lost a fraction bar again. Again, I have no idea where they go. I swear they're there when I start all this. All right, I need g of h of negative 6. G of h of negative 6. So I'm going to start by finding h of negative 6. That would be 1/2 times negative 6 plus 5. That is negative 3 plus 5. So h of negative 6 equals 2. So since I want g of h of negative 6, that means I want now g of 2. That's going to be the cube root of 2 times 2 minus 3. So that's the cube root of 4 minus 3, which is the cube root of 1, which is 1. So g of h of negative 6 equals 1. There you go. Okay. Now for the last section. Says determine if the graph represents a one-to-one function. All right, well, one-to-one function, remember, first of all, it has to be a function, so this passes the vertical line test, we're good. Then we have to look and see if it passes the horizontal line test. It does, so that means yes, it is a one-to-one function. On 46, when we double check to see if it's a function, it doesn't even pass the vertical line test, so that's a big fat no. 47 passes the vertical line test, so this is a function, but it fails the horizontal line test, so it's not a one-to-one function, so the answer is no. Okay, and that's it. So make sure you are ready for your test on Monday. Make sure you also look over, you can go back through some Delta Math stuff, you can go back over your quizzes, go back over your notes. You have potential to do very well on this test, just make sure you're actually prepared.